In this question, I'm going to show you another application of the horizontal circle. And this is very important question. It is given in the book. I have seen that. But this question is also asked by IB many a times. So that is very, very important for us. The diagram shows a horizontal disc with a hole through its center. A string passes through the hole and connects a mass M on the top of the disc to a bigger mass capital M that hangs below the disc. Initially, the smaller mass is rotating on the disk and the radius is given as small r. Determine the speed of mass m b such that the big mass stands still. Now, we are now considering this scenario. So let us first learn about like how many forces are there, how are they behaving, what is happening. So the weight of this m is acting downwards, which can be taken as capital Mg. So it says that the velocity should be given to this. Let us say we are giving velocity like this, and it starts revolving around the center here. When it is revolving around the center, this force is balanced now. Now the question is, which force is balancing it? Now you are not considering centrifugal force because that is not given in IB. Centripetal force is given. So mg is going down. So this is mg is acting like through this, obviously like this. So if it is stagnant here, if you just don't move it, let us say it is not moving, the body is not moving. So this body is acted upon by a force which this F is equal to mg. So clearly this body will be going into this and this mass will start moving downwards. There is no doubt about this. But now he says that we have to give some velocity here so that this body does not move. Now, you see how easy it is to understand this question with the help of centrifugal concept. Although it is not considered in IB, we will say that if it is moving in a circular fashion here, it is being acted upon by a force which is centrifugal. Okay. I give you two explanations for this question. One which is kind of liked by IB and another which is easy to understand. Both of them I would be giving you. The first explanation is from the point of view of centrifugal. Now, clearly, the centrifugal is in the opposite direction and the weight is in the opposite direction. So they are balancing each other. So it's very easy to understand. So mg will be equal to the centrifugal force that is experienced by the small m. Clearly, the magnitude of centrifugal force will also be mv square by r, which is equal and opposite to the centripetal. So it will be mv square by r only. Accordingly, we can find the expression for the velocity. And this velocity will be capital mgr divided by this, and you can take the square root, and there it is. This is your answer. Clear? Now I am coming to the explanation which IB wants you to give. If the same questions comes into your paper too, they will not give you mark for this explanation. So there has to be some other explanation. Now this is, as I told you, this is your rough work to understand like what is happening, what should be the right answer. Now after this, if it is paper one, you can clearly find the answer very quickly. Let us go for the another example explanation. We will say that there is no such force. We don't know this force. We will say that the only force which is acting towards the circle is m into g, and it is moving in a circular fashion, which means that mg is now acting like centripetal. So mg force which could be used to pull the body, which could be used to pull the body, this mass m towards the center, is not pulling the body. Why? Because this is now acting like centripetal, so it is doing some other job. That is why it is not able to pull the body towards the center, and we can say that the centripetal force will be equal to the weight, which is mg. And clearly in this also it will be mv square by r is equal to mg, and you would be getting the same expression as earlier. But the explanation is not that very satisfactory. Like, this is what IB wants you to do. This is what IB wants you to say, that the force mg is acting like centripetal. And you can clearly write that, and you can even find the answers for that. But it is not that convincing, isn't it? More convincing explanation is the explanation number one, that there is a counter force, the reaction force to the centripetal, which is the centrifugal. and this centrifugal is like mv square by r, which is equal to mg. So clearly these two forces are balancing each other, and that is why the velocity required will be square root of mgr by small m. So why I cited this example? Number one, this question has been asked by IB in the previous years. I think it was asked in paper two. I think recently they have asked. I don't recall. I don't recall. Um, might be paper one recently, 2022 or 21. Number one reason is that. Number two reason is that I wanted to discuss horizontal circular motion. So this is one of the most important examples to be cited in the cases of horizontal circle. And point number three, I wanted to clarify you the concept of centripetal and centrifugal. So it's very, very clear here that yes, centrifugal concept is very beautiful concept, but yeah, you cannot talk about it. Okay, dear students, so we would be moving into the next video now. And in the next video, I'm taking another example of horizontal circle, which is very important. Do not miss that. And then we would be moving to the vertical circles. Okay, then see you there in the next video.